we go. Hey, I'm recording. So, let's do this. First one, circle. Circle. Yeah, you already got circle. Okay, so, circle. Here's the definition. Okay, here's the definition of a circle. A locus. Yeah, a locus. Not like. Okay, not like that. That has a T on it. Not that.
Oh, a locus.
A locus. This is a group. That's what that's called. A group. That's what it means. Okay? A locus of points in a plane. A group. It's just a group of points in a plane that, you know, us math people, we want to sound smart every once in a while, so they made up a word and said, hey, let's call it locus without a T. And it just means a group of points. That's right. A group of points in a plane. Equidistant. Equidistant. No, but that's what it means. That's another one of those, I'm so smart, I'm a math person words. Alright? Equidistant are from a given point which is the center. Yeah. And y'all, the center is called HK. Yeah, we did. HK. Okay, so let me show you. Now look, that's 10 points right there. It has to be verbatim, just like that. But guess what? Well, I don't care about comments. Four definitions, and guess what every one of them start with? A locus of points in a plane. Alright, so please tell me you can at least get 8 points. That's 2 points for every one of those little sections. Okay? So, let me show you what it looks like. Alright? So, there's my locus of points. There's my group of points. They're all, guess what? They're all the same distance from this given point, which is my center. Okay? Ellipse is a lot. Yeah, we're going to draw all that stuff. Nope. I'll write exactly. I'll put the point value in pink for everything. Okay. Now everything that that's your test. Everything that's highlighted.
Oh, okay. Everything else
kind of has a yellow mark back. Okay. So listen to me. A locus of points in a plane, equidistant from a given point. What is the distance? R. The radius. Okay? All these points on my circle are the same distance from this given point. Now, does that make sense now? Okay, it's kind of a weird way to say it, but that's the proper way to say it. Okay, so let's do this. How to tell. Now, this is going to be on your test, but you're not going to have to write this, but you will have 20 problems, and you'll have to tell me if it's a circle, ellipse, hyperbola, or parabola. Okay? Now, I'll tell you this. First of all, if you want to know, if you want to be comparing all the stuff, when you compare it, it has to be on the same side of the equal sign. Okay? You can't have an x squared on one side and a y squared on the other side and be talking about them. They have to be on the same side, so you have to put them on the same side. Okay? So, here it is. Everybody look at me for a sec. Here's an x squared and here's a y squared. Okay? If they have the same sign, they will make a circle. Alright? If they have the same coefficient, it will be very round. Alright? So, how to tell if it's a circle? It has to have an x squared and a y squared. They have to have the same sign and the same coefficient. Does that make sense? Y'all listen to me. I said when you're comparing the x squared and y squared, they have to be on the same side. All right? If they're not on the same side, you move them to the same side, and then you talk about them.
So, you're going to give us an equation on the test and we have to determine with? Okay.
Yeah, and we're going to practice some of those, okay?
Okay.
After I teach them all to you, I'm going to give you a list of them and say, hey, tell me what these are. You can do it. You'll do it really quick. It's not hard at all, okay? And the reason is because it's going to make sense. It's going to make sense to you. Okay. All right, so here's the equation of a circle. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Notice what I've always taught y'all. X's go with x's and y's go with y's. Huh? What? Nope. Only what's in, let's just say what's in white. Okay? What's in white is going to be on your test. Everything else will be used to work your problems. Okay? Everything else will be used to work your 12 problems. And I'm going to say this. If this were an upper level math class, they would make you memorize all this math. It would be intense. Okay? No, you're not all the stuff that we have to find. So there's my circle. Here's every time you're given a circle, you're going to have to do 3 of them. You're going to find the center. That's HK. You are going to find the radius. That's R. And then you are going to graph it. Okay? So everything that you're going to use for your little worksheet, I'm going to put it in a yellow box. Okay? Now, I'm going to write this down. Don't write this down, okay? But I'm just going to show you. It's going to look something like this. That's what it's going to look like. It's not going to look like this right here, guys. Okay? So, if I want to know if that's a circle, first thing I have to do is what? Put the x squared and the y squared on the same side. Now, do I care about anything else? No. If I'm just trying to tell what it is, I'm worried about the x squared and y squared. That's all I care about. So you put them on the same side. They're both positive. It has an x squared and a y squared. They have the same sign and the same coefficient. Bam. It's a circle. So what will you do for the worksheet? For the worksheet, you'll put the x's together. You'll move this over, put the y's together. You'll complete the square. So you have a quantity squared. All right? And then it'll put it in the proper form for you. But we're going to do one of those, and it'll be okay. It won't be too bad. No, you're getting a worksheet probably Tuesday. If you put it in a calculator. The calculator has the ability to graph circles, but you're not going to use the calculator. Okay? All right. So, here's the other thing. We got to draw a picture. Now, all of these things are called, does anybody know what they're all called? Conic sections. Why are they called conic sections? They're made from a what? A cone. That's why they're called a conic section. All right? So, look, I made a cone. Here's my cone. Okay? This cone has an axis. It goes right through the top of it and comes out the bottom. Right down the middle of it. I want to know, what would I have to do to this cone to make a circle? I'm going to cut it. Where am I going to cut it? Horizontally? Can it be slanted? No. It has to be what? Straight across? Okay. Could I cut it anywhere? All right. So that's what we're going to draw. That's your picture that tells me how to get a circle. We're going to draw a cone. Notice this is white, so what do you know about it? It's going to be on the test. And then we're going to take a plane and cut it. Not like an airplane, people, but like a plane, like geometry, okay? And how do you have to cut it? Straight across, okay? So we're going to write that. How do I get a circle from a cone? It is a plane, and it has to be perpendicular to the axis. If you slant it, guys, it's not going to be a circle, okay? Perpendicular to the axis of the cone, and it crosses both sides. Okay? So this picture is worth 3 points, and these words are worth 2 points. There's your 15 points on your test. Huh? Each definition is worth 15 points. That's 60 points right there. The other side's worth 40. 20 problems, 2 points apiece. Okay?
Sorry. So this each circle is worth 15 points and each circle is worth 15 points?
Mhm.
Okay, so these will all be worth 60 points?
Mhm. Nope, it's a 100-point test. Okay, so now let's do Ellipse, because he has a lot more. All right, Ellipse, a locus of points in a plane. Such that, we had that argument one year, such that the sum of the distances between two fixed points, which are called foci or foci, depending on how you want to call it. Okay? It's obviously a focus, but there's two of them, like radius, plural is radii, octopus, plural is octopi. Okay? So two fixed point foci is constant.
This is extremely also, but saying foci reminds me of it. What's the word rhinoceros?
I don't know.
Yeah, I didn't know if it was rhinoceros. People.
And it's thermoses, not thermi.
But thermoses sounds right. Rhinoceroses.
Rhinoceroses sounds okay. I like rhinoceroses. Okay? 10 points right there. Yeah, it could be like deer. Yeah, like deer. I saw 5 deer, or that's a deer. There you go. All right, so there's my 10 points. Okay? How to tell? Now let's think about this. Yep. How to tell? Think about it. Does it have to have an x squared and a y squared? Yeah, remember what I just told you. Here's x squared, here's a y squared. Okay? So it has to have an x squared and a y squared. Yes, always, anytime I'm talking about them, they have to be on the same side. Do they have to have the same sign? Yes, they do. That's what makes them go together. All right? To make an enclosed figure. What about their coefficients? Yeah, it depends on what side. That's right. That's what's going to make it what? Yeah, elongated or something. Smashed out, pulled out, whatever we want to say. Different coefficients. That's what's keeping it from being really round, right? It's not the same all the way around. So, a circle is an x squared and a y squared, same sign, same coefficient. An ellipse is an x squared and y squared, same sign, different coefficients. Okay? Well, first of all, I'll tell you this. There are two types of ellipse. There is a vertical ellipse and a horizontal ellipse. I'm going to draw the horizontal ellipse. Okay? And I'm going to show you how we get it. The because it's a conic section, but it is an oval. Okay? All right, so here it is, an ellipse. It has, it's just this group of points, this locus of points. I got these two fixed points. We call them C. Okay? Because I'll tell you how to find where they are in just a little bit. All right? But here's what it says. It says the sum of the distances between two fixed points is constant. That means it's always the same. So here's what it's saying. If you measure the distance from here to here and then here to here, and you added them up, it's going to be 2A. And y'all look, it doesn't matter where I go. I can go here and here. It's 2A. Here and here. It's 2A. I can go here and here. It's 2A. I can go here and here. It's 2A. Do you see what I'm saying? Okay, so let me talk to you for a second about this.
You might want to know if either rhinoceros or rhinoceros.
Okay, so do you know how to make a circle, like you want to make a circle bulletin board, a baseball bulletin board, okay? Y'all know how to do that? You take the board and you put a nail in the center, tie a string onto the nail, a string on a piece of chalk, and you go around like a big compass. Y'all know that, right? Y'all done that stuff. Okay, let me show you how to make an ellipse, okay? Instead of one nail, I want two nails, okay? And then you're going to take a piece of string and you're going to tie it in a circle, all right? I'm going to hook it around those two nails, and then I'm going to take my pencil and I'm going to go stretch that string out, and it's going to keep that pencil all like that.
I had run into that one side and figured out what those sides were.
You put the string around both nails.
Strings around those nails, and it'll just come and it'll make a perfect oval. Okay? So that's the way you make an oval. Alright? Pretty cool. Pretty cool. Go home and try it. Okay. Alright. Now, let me tell you this. D sub 1 plus D sub 2 is equal to 2A. That means the distance from one focus plus the distance from another focus, that's that constant, 2A. Alright? And it wouldn't matter where I went. Y'all go anywhere. Okay? But those are always the same. Alright, let me show you what the equations are. For a vertical one, it is y minus k quantity squared over a squared plus x minus h quantity squared over b squared is equal to 1. For a horizontal one, it is x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Now, let me show you where the a's and b's are. Alright? This is called, now look, it has two axes, right? You see them? One's a major axis and one's a minor axis. Which one's the major axis? The longer one. Y'all, whichever one's longer. This one's horizontal. Guess which way this one's going to be? Vertical. That's what makes the thing say it's vertical. Okay? This distance on this one right here is A. This distance right here is B. So the major, what's the length of the major axis? 2A. What's the length of the minor axis? 2B. Okay? Now, how am I going to know which is A and which is B? Huh? That's exactly right. A is the biggest. A is the biggest. He's the biggest one. He's determining which way it goes. You look at these two numbers and you go, who's the biggest? This guy's the biggest. And watch this. This guy's underneath the Y, so that thing's running vertical with the Y-axis. You see how that makes sense? This guy is the biggest. He's underneath the X, so he's running with the X-axis, and that's what makes it horizontal. Okay? Now, let's talk about the stuff you have to find. These are the things that you have to find on an ellipse. You have to tell me, is it horizontal or vertical? You have to tell me what its center is. Now, what's its center going to be? Look at those equations. HK. The center of every conic section, HK. What's the length of the major axis? You've already told me this. 2A. What's the length of the minor axis? 2B. All right. And then you're going to have to graph it, just like we did on the circle, okay? And then you're going to find one more thing. This thing is called its eccentricity. And it is E, okay? And it's equal to C over A. C over A. Now, here's how you find C. C squared is equal to A squared minus B squared. Kind of like the Pythagorean theorem, but we got a minus sign instead of a plus sign. Okay? Now, here's what eccentricity tells. The eccentricity tells how round the ellipse is. How round the ellipse is. All right, so let's talk about it. The rounder the ellipse, the closer E is to what?
What?
The other way. The closer E is to 0. Okay? Because think about it this way. He has 0 stretch. Alright? The more elongated the ellipse is, the closer E is to 1.
So circle has 0,
That's exactly right. He'll be the same. That's why he doesn't have any focus points. Alright? Okay, so we like the picture, right? We like the picture. So what am I going to do with this cone right here in order to make not a circle, but an ellipse? I'm going to cut it, but how am I going to cut it? At an angle. Now, does it have to go through both sides? If it didn't go through both sides, what would it be? A what? Yes, a parabola. So you have to say it has to go through both sides. So it's going to look like this, all right? And this time it's going to be a plane that is what?
diagonal.
Not perpendicular. I don't care, but it's not perpendicular to the axis. That would not cross both sides. Okay? That would not cross both sides, so that would make a parabola. All right, a plane not perpendicular to the axis, but it crosses both sides. Very important that it crosses both sides. Do what? Uh-huh. That's it. So this is your 3 points, and this is your 2 points. Okay? All right.